Hello everyone. In this video, we'll be discussing how to interface and decode DHT11 communication protocol. Here is the learning outcome. By the end of this session, students will be able to interface DHT11 temperature sensor with Arduino and decode the communication protocol using logic analyzer. Here is the interface diagram. There might be slight change in the actual practical prototype that we are going to see now.
Okay, so here what we have is an Arduino board which is shown in the diagram. So this supports digital as well as analog pin interfaces, as well as this microcontroller would be used to interface the DHT11 sensor, which is a temperature cum humidity sensor. And this sensor basically supports a one wire protocol. I mean, this is a sort of a non-standard kind of a protocol. As we all are aware, like the standards of protocol stand to be like UART or I2C or SPI. But DHT11 uses a different kind of protocol called one wire protocol. So this is very important to understand how this works. If probably we have a look at the data sheet and try to decode these signals, could we be able to understand the language that is set up between a sensor and a microcontroller? So let's have a look at it. And for decoding these logic signals, I'm going to use a small USB logic analyzer, which is an 8-pin logic analyzer that comes from the Solapur company. Now, have a look at the left side of your screen where I have a Arduino IDE that by default presents us with two functions, that is void setup and void loop. Now let's have a controller to program now. First one is, if you don't have if you are using this Arduino IDE for the first time, it is important for you people to just go to tools and click on manage libraries. Then it will present you a pop-up window which will probably fetch all the details from the Arduino repository regarding whatever libraries are available. And for this session, I have used DHT11 library. So you can just type in DHT11 and install the most recent version of that one. So I have already installed the DHT library. So I'm not going to install it again, and I'm going to directly include it in my program. So here I'm going to include the DHT11 library, which is named as just dht.h. So now we can move ahead and define a pin for, I can just call the pin as DHT pin so that it would be easy for us to reference in our upcoming program. So along with this, I'm also going to define another variable just to indicate the type of the sensor, and I'll be calling that particular variable as a DHT type. So in our case, the DHT11 sensor that you're able to see on the bottom right corner now, which I'm holding, is as per the color convention, the blue DHT sensor that is available in the market is DHT11, which has a little bit of less resolution as compared to the DHT22 type, which has a little bit higher resolution and preciseness when it comes down to the measurement of temperature and humidity. So as of now, since we are having the blue one, this is DHT11, hence we will be using this in our program. Now moving ahead, we have to also define a function that would accept two parameters, that is DHT pin and DHT type. Okay, so these are the two parameters that we are passing on to the function called DHT, which is already defined inside the DHT header file. So I've passed the proper pin, which has to be considered by the librarian. I have also passed the type of the sensor that we have to use. So under setup, I want to print some data to the serial console. So I have to first of all initialize the serial port with some baud rate. I have done it with a 9600 baud rate. Then we have to print something like, just for the sake of testing or debugging purposes, just to make the output a little bit readable, I'm just printing another line. I'm just printing this for the first time, the first line, which would be saying like DHT protocol decoding. Okay, so that's all with the setup. And not to forget, we have just begin the serial port, but we have to also begin the DHT function. So what this function basically does is it tries to communicate with the DHT header file, and it sets up some proper communication. There is some communication mechanism between the microcontroller and the sensor, and this call to the DHT.begin function actually initiates that primary communication. Next we have loop. Inside loop, we are going to first of all add some sort of delay so that there won't be any rush in the data, or the buffer would be full. So this is the delay that would be considered between multiple reads of a given temperature. So since we are having the temperature, we need to go for definition of we need to simply go for defining a small float variable. Let us say float h, and I'm going to again call an inbuilt function which is already defined in the DHT header file, which says which is read like read humidity. This is a function which is again defined in the dht.h header file that would read the humidity. And similarly we have another function with a name called read temperature. And there are multiple variants of these kind of functions, like we can even call read temperature, and within bracket we can pass on a variable like true that would probably read this in Fahrenheit. But as of now, currently I want to just read the temperature in degrees centigrade, so I'll leave it as it is for now and define another float variable. Let us call it HIC for heat index in degree centigrade calculation. For this I need to call in a function called compute heat index, and this function accepts three parameters. The first parameter being the temperature variable, the next one is the humidity variable, and the last parameter, let me just keep it false. Okay, I've saved it with some name. Now I'm going to upload it to the microcontroller. Let me connect it. I have only connected the microcontroller, as you can see in the screen. I think there is an issue with the connection. Now I have reconnected. Let us check. It says H was not declared. Okay, fine. There are some minor errors. On correction, I have tried to re-upload it. It is uploading. As you can see, the code is uploaded properly. Now let me open the serial monitor and show you if it is printing anything. So as of now, on the output screen, we are not able to see anything. The reason is we haven't connected the sensor. So let us move ahead and make quick connections. As you can see here, I have this DHT sensor and there are small terminologies mentioned. There is a naming given to each of these pins. The first one to which I have connected the red wire is the VCC, the last one is the ground, and the center one is the out pin. I'm going to connect this red wire, that is VCC, to the controller's 5-volt pin, and I have the last pin going to the ground, and I have the center pin of this DHT11 going to pin number 2, which we have defined in our code. So digital pin 0, 1 and 2. So I made the connections, and along with that you can also just have a look. Like here I have a logic analyzer which is 8 channel, and the first channel which is beginning with 1 and ending at 8. But in terms of our software, the Soleil logic analyzer software, which is going to analyze all the signals now, the numbering starts from 0. So we would be considering the channel 1 on the hardware of this logic analyzer as channel 0 on its software. So this is the first row, which is my red wire, that is channel 0, and the gray wire of this logic analyzer is the ground. So I'm going to connect the ground of this logic analyzer to the ground of my Arduino board, so that there would be a common ground and there would not be any miscommunication between the voltage levels in between the sensor and the board. So now when I connect this extra pin that is coming from the logic analyzer to the DHT11's data pin, so I'm going to just tap it on like this, so that I would be able to spoof the data coming out of this DHT sensor. So basically what is happening here is DHT11 and microcontroller are communicating with each other. In the meanwhile, I'm using a logic analyzer to capture those signals on the laptop. So let's check. I have tapped it, means currently logic analyzer is connected to the data out pin of this thing. But before that, let us first make sure that there is some data that is getting printed. Let me click on the reset button. Okay, so now as you can see, it is printing some data to the output console. That is, temperature is 31 and humidity is 50. So we are interested in only this particular content, that is 31 and 50. As you can see now, if I pause this, it sends out a signal of this kind. So let us move ahead and check how the ones and zeros are indicated by the sensor. So in the data sheet, it says that a 0 is communicated, through these two signal transitions, that is a 50 microsecond low level signal followed by approximately 26 to 28 microseconds higher signal. So let's just remember these values, that is 50 and 20 above, 26 above, 50 plus and 26 above for 0 indication by the sensor to the microcontroller. Similarly we have a different mechanism for a logic 1 indication, that is a 50 microsecond signal and approximately 70 microsecond high signal. So for this, we need to now go back and work with the logic analyzer. This is a software that comes with the Soleil logic 1.2.18, and as you can see, it is currently shown as connected. So every 2 seconds there is going to be some data capture by the logic analyzer. So let's see what it has captured. So if you have a look at this one, this is the first octet of the data according to the data sheet, and this is the second octet, this is the third octet, and this is the fourth one. So the first one and the second one actually shows us the temperature. So if we try to read this, it is 56 and 20 microsecond, and as we have seen already in the data sheet, like the signal that corresponds to 0 indication is 50 plus and 20 plus. So 50 20 50 20 50 20 I can read it as 000000000. So the first octet is all 0. The second octet is a 000 and then a 1 1 1 1 and a 1. 0001111. If I try to convert that into a decimal value, it reads 31. So let's go back to this COM and check what was our temperature. The temperature was exactly 31 degrees.
Here are the references used for this video. Thank you.